Because it just said 3, 2, 1, go. So we're 3, 2, 1 going. All right. Hello. So, couple of things right off the start. So first off, let's talk about the last test of the semester. You are going to have a test tomorrow in class on 4547. Okay? So there's that going on. Okay? Not many of you, this doesn't pertain to every single one of you in the room, but there are some of you that are missing some semester 1 type things. Those need to be made up by this week, Friday. Okay? Then the big one here is tomorrow you'll need your Chromebook because your test tomorrow is going to be on its learning. Okay, so Chromebooks tomorrow.
Is it like test, like summative?
11 points. Yeah.
Oh.
Yeah.
Okay.
Tomorrow I won't be here because I'm doing some field trip.
Okay.
So should I just do it like when I get home?
That would be awesome.
How many questions are on the test tomorrow?
11.
Oh, well, you got 11 points.
Yeah. Yeah.
Okay.
I think it's 11. I don't remember.
It might be 12.
I know that it's 11 points, but it might only be 9 questions.
Is it just like multiple?
You know what I mean? 'Cause there might be a couple of like
Yeah.
tick and tick or fill and fill. Yeah.
I got a question.
Yeah.
What-
So I haven't. We're using last year's. Let's use last year's. So yeah.
Do we only have one worksheet for this unit?
Yes.
Okay. I just want to make sure.
Until I hand you this one.
Okay.
Yeah, which I'm going to hand you this one in about a half hour.
Is it just like multiple choice?
And some fill-ins and some. There's only one where you got to write a 500-word essay. Okay. All right. So more importantly, it's weird this year. It's just how the calendar fell and the days and all that fun stuff. Usually there's 2 weeks after we come back from winter break, and then before finals this week there's only one, or this year there's only one. So your final is next week, Wednesday. It's in 8 days. Okay? So it's going to be 30-ish questions. Some of it will be multiple choice, some of it will be possibly fill in the blank type ones, but it's going to be on pencil and paper. No, 15 I think is what I looked at. Yeah. Okay. So if you are a Roth grader, because he's got 2 sections, so if you are a Roth grader, your day 1, period 1. So that's Wednesday morning, 7:50. 7:50. Up in 341. Okay, 341, 343. It's one of the corner rooms upstairs. Okay. If you are a Mrs. Hill or a my grade E, then we're going to be same day next week, Wednesday, but we'll be period 3. We'll allow you to sleep in a little bit. Okay. Just how it works. Okay. If you have a conflict, okay, with your selected time or your scheduled time, then we'll talk about that tomorrow or the next later on this week, and you'll go to the other one. Okay. Any questions, comments, concerns, clarifications on any of that so far? Big one is tomorrow. What do you need to bring to class?
A Chromebook.
Chromebook. Charge preferably because then that way you won't lose the power. You got the power. All right. So tomorrow's test is going to be on sections 4, 5, and 4, 7. Now those were last year's topics. Get it? Last year. Dad jokes. Okay. All right. So the topics that are going to be on that online test are going to be these. I think that's it. I thought we could get them all on one page or one screen. Are going to be these right here. So it's going to be section 4.5 was graphing tangent, cotangent, cosecant, secant, and those graphs. So there might be a question along the lines of here's a trig function. Which one is it? Okay. Or there might be here's a trig function, go graph it type question. Okay, so we've got those type of questions. And we'll get into these in the next couple of slides, but it's all about the asymptotes. The asymptotes give away which one it is. You got that going on, which is nice. Okay? Then, after we got done doing that, then the week before break, we talked about inverse trig functions, and we were evaluating it from the unit circle. Okay? And that, remember, is tangent and sine, inverse tangent and inverse sine are on the right half of the unit circle. And inverse cosine is on the top half of the unit circle. So we found angles, and that was all fun and great. Okay? And then, right towards the end, the last couple of days, the last 2 days right before break, we talked about composition of trig function. That's when you got multiple ones, when you got two functions going on at the same time. Okay? Sometimes they can be on the unit circle. Sometimes you got to make a reference triangle for it. Sometimes it's going to be algebraic type one. But then again, you just make a reference triangle for it. Okay? So we got that stuff, which is nice. Now, because I like you, I'm going to tell you. Oh, well, maybe I don't want to tell you. You plug your ears.
Okay.
Yeah.
Tomorrow on the test, we will be covering up all of the unit circles.
Why would you do
I'm gonna bring my.
We're going to cover that up.
that? No, you can.
Yeah. I don't know.
So can we get on this
No,
lid and, like,
that's
draw it
much.
out? The tank
I'll
might
think
break.
the tank in here.
Oh, really?
What?
Weaken the tank?
Well, it's just a lot of.
Gotcha.
Trauma.
Gotcha. What am I doing?
We get a loose lid paper.
Make your own?
It's just anorexic.
Yeah. All right, let's get into some of these problems and let's get thinking back about all this good stuff. So, identify the graphs of them. And we said that the asymptotes give it away. And that really is true. Okay? Because if you think about it, I'm going to write this. I can write this up here. So if I've got tangent is really sine over cosine. Right? So where is that one going to have asymptotes? Where what is there? Where cosine, right? Yep. Sorry, I was looking at the x and of the theta, is what I was thinking. But yes, where cosine is 0. Okay? So where does that happen on the unit circle? At the pi's, right? No. Sorry, yes. At the over 2's, right? Yeah. At the over 2's. Okay? So that's going to have an asymptote at every pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2. All of the over 2's are going to have an asymptote here. Cotangent is just the reciprocal of that, right? So cotangent is going to be cosine over sine. So that's going to have asymptotes at all of the whole pi's. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Okay? All the way through. Secant and cosecant are basically the same as tangent and cotangent. Because tangent is the same as, because we're over cosine, so that would be secant. And cotangent is like cosecant. The difference between those two is tangent and cotangent are waves. Secant and cosecant are parabolas. So really, when it's all said and done, you have to look at two things on a graph. First thing you look for, where are the asymptotes? Okay? So if I'm looking at this first graph here, okay, my asymptote looks like I've got an asymptote right here at 0, right? Okay. Well, at an angle of 0, which one is 0? Sine or cosine? Sine is 0, right? Okay. So that means that sine is 0 in this particular one. Second thing I look at is the shape. Is it a wave or is it a U? It's a U. So sine is 0, or when I'm dealing with sine being 0, this one is cosecant. I'll put theta this time. Because the two things I look at. Where's the asymptote? What's the shape? So if I know that, what's this next one then? Secant, right? Because it's parabolas, and it has an actual value at 0, right? Yep. So this one is C. Which ones are these two? Okay. In which order? First one's cotangent, because I've got an asymptote right there at 0, right? And at 0, sine is 0. So that's cotangent. Looking at two things when you're looking at this. So with that being said, right? And there's only 4 to choose from. First one is what? Cosecant. Yeah, it's got a 0 asymptote, vertical asymptote. Second one is cotangent. Exactly.
Wait,
Yeah.
so can you, like, move those around?
Like, what do you mean?
Like the stuff that we did earlier, where we put, like, the ABC values in it.
The A is not going to really do anything.
Yeah.
Okay. The B would change. I mean, it would shorten up where your asymptotes are, kind of, so that B and
Is that gonna be on?
no. So then we moved on to inverse trig functions and using them. Okay. So we got to make sure that we're in the proper range. So here are the 4 problems that I would like to do. Arctangent of -√3, inverse cosine of -1/2, inverse cosecant of -2, and inverse tangent of 0. Okay. Okay. So let's talk about these. Which one do you want to do first? Arctan? Okay. So arctangent. Where am I looking, Reed, for arctangent? Probably want to pay attention more then. There you go. Okay. All right. So where am I looking for arctangent? Which side of the unit circle? Right? Right half? Agree with right half? Okay. So we're looking right half of the unit circle. So I'm looking somewhere over on here. Okay. Where is the tangent negative square root 3? So I'm looking bottom quarter, right? Okay. So I'm looking in quadrant 4, because quadrant 1, everything's positive. So I'm looking for sure in quadrant 4. All right. 5 pi over 3? Ooh. Oh, yeah.
Oh, yeah.
Would 5 pi over 3 work for us?
No.
No, it wouldn't because it's outside of our range, right? So, negative pi over 3. Remember that sine and tangent have to live within that negative pi over 2 to positive pi over 2 range. Sine, it's inclusive. Tangent, it's exclusive. Because that tangent, you got asymptotes there. Yeah? Wait, was that a wait for me?
No.
Oh, okay. Fire it up. Or are you just playing?
Oh, I was fresh.
Oh, okay. It looked like you were getting ready to. In your brain, it was formulating the words to come out of your mouth. Cosine, inverse cosine. What half am I looking at? Top half. Okay. So top half of the unit circle. Where is cosine negative 1/2? Is that legal?
Yes.
Yep, that one's legal. That one doesn't have those goofy restrictions that sine and tangent do. Okay. Cosecant. Top half or right half?
It could be high.
No,
No,
can only be
not-
one. Why?
Obviously,
Secant is reciprocal of sine. Yep. Okay. So that means we're right half. Is what? Secant would be top. Yep. Yep. Because it's attached to cosine. Okay. So look at right half. Where on the right half is, so this is basically, I mean, let's be honest, this is the way I think of this. This is inverse sine of negative 1/2. Because if I reciprocate cosecant, it becomes sine. And if I reciprocate negative 2, it becomes negative 1/2. So where right half of the unit circle is sine negative 1/2. What do you get? Negative pi over 6? Yep. Negative pi over 6. Inverse tangent of 0. Which side am I looking at? Right or top? Right half. Okay. Where on the right half is tangent equal to 0? Zero. Tangent is sine over cosine. Y over x. 0 over 1 is 0. Questions, comments, concerns, clarifications? Then we move to compositional functions. That's when we've got, multiple functions going on. Sometimes we're on the unit circle, and the next 2 slides we're going to be off the unit circle. So we're going to have to do some more with that. Okay. So what I want you to do right now is I want you to find me the secant of the arc sine of the square root of 3 over 2, and I want you to find me the arc cosine of the tangent of pi over 4. All right, so if I'm looking at arc sine, I'm looking here at arc sine of the square root of 3 over 2. I'm saying to myself, self, where is right half of the circle sine equal to square root of 3 over 2? That would be at pi over 3. So then I'm basically asking the question, what is the secant of pi over 3? Which is 1 over x, or 1 over cosine, yep, which would be 1 over 1 half, which would be 2. Who said, where did I get the 1 half? Okay, secant goes with cosine, right? Okay, so this is, do you understand how I got the pi over 3?
Yeah.
Okay, right? So then I'm looking here at pi over 3, I'm looking at the cosine, and it's 1 half.
Oh, okay.
With me?
Yeah.
1 over 1 half is 2. Yeah. Tangent pi over 4 is what we're looking at first. Tangent at pi over 4 is sine over cosine. Root 2 over 2 divided by root 2 over 2 is 1. So this is arc cosine of 1. And you got, so that's where top half of the unit circle, cosine is equal to 1, is 0. Yep. 0 degrees or 0 radians. Works for me. Questions, comments, concerns, clarifications? What's up?
The table is
Right there. Probably somebody spilled some bubble around.
no, it's like
I was saying somebody probably did earlier today. Let's jump off of the unit circle now. Okay, so let's do a composition, but let's go here again. Okay, so first off, I'm looking at arc tangent of -3/4. Where would I be looking for when my arc tangent, or what quadrant I should say? Let's be a little more specific. Which quadrant am I looking at for a negative arc tangent? Can we go basic? 4. Is that what you were doing with this? Yep, 4. Okay, so we're looking at quadrant 4. So I'm going to draw myself a quadrant 4 triangle. Right? Now my actual theta is there, but I'm okay with just drawing a quadrant 4 angle. Okay? Tangent is what? From your SOHCAHTOA days. Opposite over adjacent, right?
Would you rather have us calculate this in radians or actually
I'm not calculating at all.
tangent?
I'm not calculating at all. Promise. Watch. Okay? Right? So opposite side from this one would be over here. Let's make that one be our negative.
that would make sense.
Okay? The adjacent side would be this horizontal, which would be that one right there. Right? Okay? What's the one missing length of my triangle that I don't have?
5.
It's 5. Okay? Because it's Pythagorean theorem 3, 4, 5. Okay? You good, Joe? Okay, sounds good. Okay? So, now, Mason, what you were saying is that we got to go to our calculators, we got to figure out what this theta is. Right? But I'm saying, no, because yes, I agree that this is a theta, but I'm just going to use that angle, to find the cosecant of that same angle. Okay? Well, what is cosecant? Opposite of sine, right? Okay, or not opposite,
Yeah.
reciprocal. Okay, I'm with you. So what is the sine of this theta? Negative 3/5, right? So we take the reciprocal of that, negative 5/3. Okay? So we don't, the actual angle is just a middle point that we can calculate it, yes, but we don't need to calculate it.
Okay.
Yep.
I get it.
Yep. Good? Did that answer your question? Oh, okay. A distraction. See, I'm going to get back to the teaching role. Where kids are asking questions. Alright? I don't think I had another one down here. Did not. Now, same thing, except now it's an algebraic one. Oh, man.
Wait, what?
Yeah, exactly. Okay? So, arc secant. What's arc secant? Or which half of the unit circle? Why?
Because it's opposite cosine, or reciprocal
Cosine. Okay? So that's top half?
Still gonna be on top.
Okay? So top half of the unit circle, or top half of a coordinate system, which one is positive? So basically I'm asking, where do I put my triangle? For positive? Quadrant 1. Okay. So there is my triangle. Here is my theta. Secant is the reciprocal of cosine. So really, this is saying here that the cosine of theta is 3x over 1, right? Which means what? So, but which one would be the cosine? Which side of the triangle, I should say, would be 3x? Bottom line, right?
Yeah.
Right? This one? And then this one? Right? What's wrong?
Or should the hypotenuse should have the small number, right?
Well, it can still be small.
Because we don't know what x is. I'm with you. But it is this way. Okay? So what's the missing side?
Let's find out.
What is it? Oh, what is it? What do we got to use? Pythagorean theorem. Now everybody's grabbing their calculators, but is their calculators going to help in this one?
No.
No, it's not. Okay? Because we don't know what x is. If we knew what x is, yes, then we could easily go to our calculator, boom, find it. Okay? So, Pythagorean theorem says a squared plus b squared equals c squared. What's my a?
3x squared.
3x. And I gotta square that. I don't know what my b is. What's my c? 1. So this is 9x squared plus b squared equals 1. Nope. What do I gotta do next? Joe? Subtract 9x squared. And then square root everything. Yes, ma'am. No, it would not. Because if I factor it, it gets me 1 minus 3x, 1 plus 3x. It doesn't get me 1 minus 3x, 1 minus 3x.
Why would it be cosine of theta and not
It just because I just was using it to deal with because it's cosine. Yeah, it should be inverse cosine, yes, but I wanted more to get where things were on our triangle. Okay? So now, again, waypoint. Now we're just basically finding the cotangent on this triangle. So cotangent is what? X over y, right? So that would be 3x over it's not worth it. I wholeheartedly agree. Other than making it better like that. Had a little tail on my axe. I got rid of it. Chopped it. All good.
packet?
Packet time. Review packet. Love it.